All right, so we talked about branching. Now let's talk about looping. There are situations where you want to, instead of skipping a line, you want to repeat that line multiple times. Consider this situation that we want to create a list of n numbers. I chose 25 right now. How would you go about doing it? Of course, you can type it out because there are few, but if you want to do something larger, you can use a loop. Yeah? And this would go like this. While, we'll start with an empty list here. We're still on a task. L is equal to the empty list. Wrong keyboard is equal to the empty list. I will need another variable in which I keep numbers, and I initialize it with 0. And while n is smaller than, I want 25 numbers, so swallow it 26. What I will do is I will append n to the list, l.append or number n. And now I will increment the number n plus equal to 1. Don't be scared by this plus equal thing. This is just a shorthand. It's a shorthand for, oops, sorry for that. That was autocomplete. I actually just wanted the tab space here. Doesn't matter. So that statement is equivalent to the one that you've seen before, namely n plus 1. Yeah, so you take the value in n itself and add 1, an increment. Right, so we incremented n, and at the end of this, I want to see what happened with our L variable. So I want to print it out, print L. Right, let's see what happened. We got the list that we desired, namely 0 to 25, all the numbers in there. Why? Well, this is because of the fact that we repeated these two statements 26 times. Yeah? How did it go? N was originally at 0. Now we get into this head of the loop, of what is called a loop, and you can see here that you have a Boolean statement. Yeah? So this evaluates to a Boolean. Right now, n is 0, which is smaller than 26, so this evaluates to true. As long as this condition here evaluates to true, yeah, you will not get outside of the loop. Python knows that it should only execute the indented codes right here, namely line 6 and line 7. After these two are executed, the condition is checked again within the head of the loop. Yeah, after the first run through the loop, we put 0 in the list, and then we added 1 to our loop variable, to n. Alright, so n is now 1. 1 is still smaller than 26. We append 1 to the list, add 1 to 1, we get 2. 2 is still smaller than 26, and so on and so forth. And at the end, we will get 25 here. We append it, we add it. 25 plus 1 is 26. It's not smaller than 26. This evaluates to false. And finally, we get out of the loop here. That's how the magic happens. Now, we can also use a different syntax to do something similar, namely for loops. And this goes like this: for I in range, for the same thing. Yeah, we want 25 numbers in range 26. What we do is we append to L dot append the number I. This can be any variable, but it's generally I or J or some such are used. L append I, and then we do nothing. We will just print the list at the end. Print list. A list that I want empty in the beginning of the loop. L is equal to this. And let's see what came out. Exactly what I expected it to. Right? Okay, so how does this work? Well, this is something of a special object, but you can consider it something like a list. I will show you this explicitly. The point is, you have here I becoming first, it's 0 in the beginning, then it becomes 1, then it becomes 2, and so on and so forth, up until 25. And the change in the value of I happens every time you exit the loop block here. By exit, I mean you check the loop head again. Yeah? Okay, what's with this range thing? So this range is a special function. Not so special, but anyway. You start with a starting position. Let's say it's 0. Then you give it an end position, 26, and a step. That it would be 1. If we write it like this, we will get exactly this sequence. So this is not really a list, but it behaves like a list when looping over it. And you can explicitly make it into a list by typing that keyword right there. Okay, so list of this is indeed what we had there. Let me print it for more explicitness. Print for more explicit list. I like the compact version of all of this. All right, but range can do multiple things. It can go, you can change its starting position. You can say this will be 2, not 0 anymore, and you can change the number of steps too. Let's put it to 2. Now we'll get all the even numbers between 2 and 26, 26 excluded. Similar to slices, the last index is excluded. So let's see what happens. Exactly what I told you. Even numbers from 2 inclusively to 26 exclusively, so up until 24. All right. So you can use this range to define a loop without the fear of, let me show you what happens with this while thing if you forget to increment that variable. What would happen here is what is called an endless loop. Yeah, you go into it, n is 0. Something happens, you go back here, and it's still 0. Something happens, you go back here, and it's still 0, and so on and so forth. And you see the problem with this. And Jupyter Notebook might figure this out at some point, but we will not wait for it. I'll just interrupt the computation right now and fix our error and redo it. Okay, so avoid endless loops. In this sense, the for loops are somewhat safer. Okay, but you do not need to use this range object. Instead, you could just iterate over any collection. You can iterate over a list, which is effectively something that happens through the range thing. Or you can iterate over strings, for instance, or dictionaries, or. Let's do this task right here. Yeah. So consider you have this code book here. Yeah. Basically, A needs to be mapped to C, B to D, and so on and so forth. And we have this secret message right here, and we want to decode it. Let's use a loop to do just that. And now we'll iterate over this. This is a collection, namely string. So for character in code, again, whatever you want to name the variable, but it's a good idea to name them something that other people understand. And because you know in strings you have characters, char works just fine. Okay, so for char in code, what we want to do is get its mapping out. So let's say plain text is equal to the empty character in the beginning. Now what we'll do is we'll append characters one by one. Plain text plus equal, the same convention, plain text plus something. Plain text plus equal, let's comment this in. And now let's use that mapping. Shift mapping at the position indexed by this character. Okay. And I want to see the output too, because it's a cute output. Plain text. All right, so what was the secret message? It was that in Anne we trust. Right, so you saw that you can iterate over collections just like this. In such a case, yeah, this character variable takes the value of every element in your collection, step by step. First is G, then it's L, then it's Y, and so on and so forth. And the last value it takes is this of R. And if you go through the mapping, you will see that this is exactly what comes out. Yeah. Now, the last bit I want to discuss about loops is this break statement. Consider now this task where you want to find the index of the first occurrence of X within this larger string. Now, you know precisely where it is, namely it's on that position 1, but imagine it's something very large and you're only interested in the first occurrence, not in anything else. So why loop to the entire string? Up until now, that's what we did. We always went from the beginning to the end. Now, what you can do in such a case is you can find it like that, like result index is equal to 0 at first. If we're lucky, we'll find it there. And now we'll loop over this for I in range. Let's go like we did right here, yeah, over the collection itself. And call it character here. Character in I'll just copy this into a variable. Let's say string x is equal to this, and I want this as a string, of course. Sorry for that. For character in string x, where we're looking for x, we'll do a check. If the character is equal to x, this is what we were looking for, yeah? Then we will print the index. Print, let's have a variable for the index. I is equal to 0 first, and then I will be our index. Print I. Yeah, and we want to increment this, so for each character that we encounter, we have a larger index. So I plus equal to 1. Okay, we should now get 1 as an output here. Let's see, and indeed it is. That's the index we were looking for. But if we look inside this loop, print, let's say, to differentiate the strings, yeah? Result index is I. And otherwise, I'll just print I to demonstrate that though we found our result at index 1, we went all the way down to index 20 for this. To avoid that, what we could do is print, type in break at this point. Right? So whenever this break is encountered within the loop is broken out of. Right? So everything that comes below break is not executed, and most importantly, you don't go back and check for this condition. You simply get out, yeah, and execute line 12 if there were a statement on line 12. And this is demonstrated by the output. As soon as we found the index 1, though character still would have gotten instantiated to everything else from S to D to C and so on and so forth, that did not happen. Instead, break made us jump outside of the loop, so this print statement did